Hi everyone, in this video I'm going to cover the electric circuit analysis, the primary basic format of the circuit, that is type of circuits, series connection, parallel connection, properties of series and parallel with simple examples. First of all, before enter into the series and parallel, so what are the circuits? The circuits are nothing but a closed loop allowing the current to flow. Usually, these circuits are formed by a network of electrical components. Those components are include batteries, wires, switches, and then sometimes called bulb or load. So what are the source? So we have circuits, we have a network, we need to give some energy. So that energy elements are nothing but sources where the electrons start flowing. The circuits is nothing but a closed loop as we said earlier. That is the return path where electron leave the circuit. So types of circuits, we broadly classified the circuits connections based on the flow of current. We categorized in the series circuits, parallel circuits, and then other circuits. So other circuits are AC, DC, open circuit, and then short circuit or closed circuit. So coming to that main picture, series circuit. So the components are arranged one after another, end to end. Only one path is exists to flow of current. For all the element connected end to end, holding or allowing the same amount of current same through all the components. For example, if I have two resistors R1 and R2 connected end to end, that is total resistors R. For example, if R1 is 3 ohm, R2 is 4 ohm, it's connected end to end. That is called series connection. There is no other additional path exists to flow of current. So this type of arrangement is called series connection, and the resultant resistor is summation of the two resistor values. That is 7 ohm. Properties of series circuit already I mentioned. The current same through each component. In the series connection, the total voltage is nothing but voltage drop in each resistor. Voltage drop across each resistor. If you add up that is the gives the total voltage. Total resistance, that is nothing but addition of all the resistor, that is gives the equivalent resistor or total resistance. The parallel circuits, yeah, in that previous slide, usually in the series connection, equivalent resistance always greater than the individual resistance, each individual resistance. For example, if I have a 10 ohm, 30 ohm, 40 ohm connected in series, I have a total resistance of 10 plus 30 plus 40, so total 80 ohm. So total equivalent resistance 80, that is greater than the each individual resistance. Parallel circuits, the components are connected across each other, which gives the multiple paths to current flow. Voltages are same on the across all the components which are connected in the parallel branches. For example, if I connected the resistor in parallelly, that equivalent resistance is nothing but 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R2 up to 1 by Rn if n number of R resistor connected in parallel. So we have here some example. R1 equal to 3 ohm, R2 equal to 4 ohm, R is 1.7 ohm. How it will come? So 1 by R is equal to 1 by 3 plus 1 by 4. So if you take it simplified and then take R, you will get 1.7 ohm. Otherwise, you can use the formula for 2 resistors connected in the parallel. R is equal to R1 into R2 divided by R1 plus R2. So 3 into 4, 12 divided by 7, you will get 1.7 ohm. The properties of parallel circuit: voltage same across each component. The total current of the parallel branch is nothing but individual branch current. The sum of individual branch current gives the total current. Equivalent resistance always less than each individual resistance. That is the properties of parallel circuits. Other difference between the series and then parallel circuits: in a series we have only one path for flow of current. In parallel, multiple paths exist to flow of current. Components are in line in the series connection. In parallel, components across each other. In series connection, voltages divides, resistance acts. In parallel, voltages are same, currents divide. In series, circuit fails if one breaks. Parallel circuits still work if one of the branches breaks. Other circuits: AC circuit, alternating current, sinusoidal voltage or current, alternating current. DC circuits, current flow in only one direction. Open circuit is nothing but the disconnectivity of the any of the path. So there is no current flow on that open circuit. In closed circuit is nothing but a complete path. It's a current flow on the circuit. In series parallel circuits, nothing but mixture of both the series connection as well as the parallel connection. Linear circuits, values are constant. Non-linear circuits, values change with respect to the voltage and current. And then unidirectional, bidirectional, star, delta, etc. All those are coming under the other circuits. Thank you.